Welcome back to another Technique Coding programming tutorial. In this video, we're going to be finishing off the SwiftUI version of our iOS authentication tutorial. In the last video, we set up the entire project. We made our way through it pretty good. We have quite a bit already done just because SwiftUI really facilitates creating views very quickly. In this video, we're going to be finishing things off. I'm going to bring in some code from a previous video that I'll link in the description below that created the model layer, everything to do with accessing data, fetching data from the network, basically our network layer, and what I call system layer, which deals with interacting with keychain to store our access tokens. I'll bring it in, copy and paste it in, and I'll go over it a little bit. I won't stand for too long because the other video goes over everything, but as for convenience, I'll just explain what's going on. And then we should have enough time just to finish our coordinator and finish off the project today. So let's get right into it. So real quick before I get into anything else, the goal here, again, is to get to this spot right here. So basically, we've got a very simple app. There's really no bells and whistles other than the authentication part. We just want enough to log in, see the access token being used, and then obviously we want to be able to register for a new user as well. So we can navigate around right now. It will actually register my clicks. So, okay, so yeah, so right here we can just, I won't register any user right now until later on, but we can click around, we can go back to the login screen, we can hit register, we can go back to the login screen again. As you'll notice, there's a little bug. We'll finish this. If I've got time, I'll actually fix this later on in the video, where if you keep hitting register and log in, it just keeps adding to the backstack. So if I hit login again, you see we have two login screens now, so we can actually fix this. This is fairly easy to fix with the pattern I'm using. But this is the end goal, and let me log in. And of course, this is our home screen where we can then click on this button to fetch a string, which is called "you are logged in" from the backend server. I've got the backend server running locally. Those are another series of videos that were early on in this series. So take a look at that if you want to know how to make the backend. We can reset the text, fetch it again, and then log out. So that's the end goal. So in the last video, we just made our views. So if things don't fail me right now, we should be able to build this, and it should show the previews right here in this right-hand window. It might take a second. And there we have it. So we've got all of our views done. So the first thing we want to do is we want to start bringing in all that model layer stuff. So for all my apps, what I do is I create a group called model layer. Remember, there's two purposes of coding. One of them is to explain what you want to do to the computer, and the other is to explain what you want to do to humans. So we want to really organize this as best we can. It might seem like a moot point when it comes to smaller projects, but believe me, I've seen smaller projects balloon out into very large ones. You don't want to be sitting there a year down the road with an app that has hundreds of thousands of lines of code that's not organized well. So we're going to have two layers in this. And we're going to have a network layer. And then what I usually do is I call another layer system layer. In production apps, I might actually even postfix this with just layer. This is just my own preference. So then in the network layer, we're going to have two files, and one of them is going to be our network handler, and this does everything to handle network connections. So we're going to send network requests out, and then we're going to receive certain payloads back. Okay, so for the sake of time, I'm going to copy and paste what I have from the previous video in here. I'll go over it real quick. So we have an enum. Like I said in the previous videos, that when I made this, I try to organize any string constants as enums. If I want a functionality where I can list all strings and across the entire project in one file, like a localizable file, I'll actually use a package called r.swift that will help make all strings into statically referenced variables that you can reference using code complete within the project. But for the main part, if I have something like an HTTP method, always organize them in enums. The reason I use an enum is because you cannot instantiate a enum like you can a struct. Technically speaking, you can still use this as a struct, and you can organize this as a struct and then make all of these cases into static variables. I don't do that because in enum you cannot instantiate. It gives a little bit more context of saying, hey, I'm using this for statics. So I've just organized these in that way. For the network handler, the one thing we have to, I'll go over this here in a second. I just want to close this down. I'll have to import some of those errors as well. So basically, the first thing we need to do is we need to create headers for each of our network requests, and that's what this does right here. Now, I'll pause here for a second so everyone can pause the video and copy this down if needed. But basically what we're trying to do is we're trying to make our network layer as composable and generic as possible. So we're not solidifying and recreating the same things over and over and over again across all of our network requests. In this one, I've catered this to default to expect us to always use JSON. That's why you see the content type is JSON's raw value, which if I come back up to the top, the content type is right here. And we are defaulting to that within this method that creates our request for us. Now, I know I call it a request header, but it's basically just the request object. So if there's an access token, we unwrap it, and then we add it to the headers of the request using the bearer, and this space is very important, and the request is then authorized for our secure endpoint. Then from there, we've got two methods here. This is where all the kind of the meat and potatoes are, and what I'll do real quick is I will add in the errors so we don't get editor errors here. And I will not go over the errors right now because kind of simplistic, but I will add them to the project. If you need to see these, I'll just click on them real quick and you can pause the video and copy these down if needed. Okay, so that should take care of that. So, okay, so we just went over the header. Now we have the meat and potatoes right here, which is the network handler. This handler right here, basically what we're doing is we are creating the basics of the network request. And let's see, so we do that by saying, we make our request header, which is the function we just went over, and then we want to serialize this into JSON, a JSON dictionary, which is what we do here. The JSON dictionary comes from, this is the actual payload getting sent out to the server. So we say the JSON dictionary is here. We basically are just unwrapping it if it exists. Then we say serialize that to a JSON data object, and then we add that to the URL request body. We do some error handling, and then we actually make the request right here. And then the response, we say, the status code, we validate whether or not the status code is a valid one in between 200 and 299. If it's not, then we throw an error, and then if it is, then we return the data. The only difference between that one and this one down here is we are making some assumptions based on the payload right here coming back from the server. We're saying everything else is the same except for this. We're saying that rather than us returning the data and us manually decoding it and then making it into a codable object, all we're doing is we're making generic code here that says, hey, do that for us. And we have a response type right here, which adopts the decodable protocol. So we're saying, hey, because we know that the response type is going to be whatever type we give it here, decode it as that type from that data. It's a convenience thing. You can expand on this a lot more, but for the most part, we're just going to leave it at that. The other thing we need to do is we need to define our response type using that codable protocol. That's secure fetch data. I won't go over this too much. See that other video for more information on this. It's really small anyway. Secure fetch data. This just defines the type that we get back, and codable allows us to serialize and deserialize it. Now the system layer. This is where we save the access token. So we're going to actually create an access token object. This also uses the codable protocol because we will be receiving this from the server. And this is what it looks like. So just an access token and refresh token. We won't be using the refresh token in this video, but I explained that early on in this series on what it can be used for. Refer back to that intro video. I think it's like 3 to 5 minutes long. And I explain what that does. So we have an access token now, and then what we want to do is we want to go over and actually have access token storage, which talks back and forth between keychain. That's how you securely store these access tokens. Keychain encrypts everything for you. It's also saved in the cloud, and in a previous video, I talk about kind of the difficulties in using keychain. They're not really difficulties, but something you have to keep a watchful eye over. If we have time, I'll go over that again, but it's the last UIKit video. At the very end, I discuss having checks in place to see whether or not that keychain value exists when the user installs the app, because if they uninstall it then reinstall it, it still exists between installs. So moving on, what I'll do is I'll just copy this code, paste it in here. So we need a key to reference our stored value in keychain. So we defined one that's we make in such a way that's more than likely to be unique for our purposes, which we use the reverse domain name pattern that we also use when it comes to defining our bundle ID with this. And that's what I did here. Discardable result just means we can ignore the result without there being an editor error. So whenever we save a token, we have to compose a query for keychain, and then we actually have to use a query function to tell keychain what we want to do. So it's add, remove, read, those kind of things. Before we save it, we want to make sure it doesn't exist, so we call the delete method. And so we have a save, we have a get method, and I'll pause here for a second for everyone to pause the video and copy this down if needed. And then we have our delete method here as well. I'll pause again just in case anyone wants to pause the video and copy this down. So basic functions here. Let me minimize this. Just save, get, delete. That's all we need. That's our model layer. So again, I have an entire video on building this, and I explain things a lot more in detail. Go back, visit that video. I'll leave a link in the description below if you want to reference that. So the next thing we want to do is we want to bring in our router. So we need a way to define where we want to send these network requests. And we do that by using a network routes enum. There's multiple different ways to do this. I actually picked this up from a coworker of mine about a year ago, and I fell in love with it. And it's a great pattern to use. So let me explain this a little bit. So this is an enum, and each case is an endpoint we want to send a network request to. Then of course we have a base URL. This will change depending on your needs. You should change it if it's different for staging, a production server, your local server. Right now it's set to my local network on this computer, 127.0.0.1, with the port that it's running on. And then from there, we define two computed properties. One of them being the URL. So this is the actual URL that our network layer can take and then send the network request out to. And that defines each of the routes right here. So we have a URL here. This just defines everything. And as you add more endpoints, this would grow. Now you can also split it off into different enums. It doesn't just have to be network routes. You could have network routes and then a sub enum called auth, and then another sub enum called RESTful for RESTful endpoints or APIs. You can mix and match or make it as complex or as simplistic as needed. Then we have a method variable in here that just defines what type of HTTP method corresponds to that endpoint. This might look a little weird at first, but I assure you once we start getting into the other model layer stuff, it's going to make a lot more sense. So now that we have that, we are done with our model layer stuff, and we can move on to a couple of the more complex things. Now, the first thing I want to go over is actual navigation. Let me close some of these things down to make everything all nice and neat here. And you know what I'll do is I'll actually make this full screen. I'll have to just for a little bit more space here. And what we'll do is we need to create a new group called Nav Coordinators. Now, I've seen some people kind of wonder a little bit about how I'm going to be doing this. And this is kind of different than anything I've seen out in the industry right now. What I did was I used the delegate pattern for my navigation. And we can see that if I go back into my screens in the home view model, you'll see I have these delegates that say it passes the actions back up to a delegate object to handle navigation. And usually when you see some of these other patterns in SwiftUI, you don't do it that way. But the delegate pattern is still very useful, and it actually makes a lot of sense from looking at things as that you have one object that controls the navigation, which is our coordinator. That should handle all the coordination. We shouldn't have to be passing around that within each of these views, or in this case, view models. So what I did is I actually just reused that and repurposed it for SwiftUI. So kind of like in the UIKit stuff, we're actually going to have a coordinator in here. But unlike SwiftUI, we actually have to have a coordinator view alongside the actual coordinator. And the reason for that is the view is in charge of the actual navigation. So as it would be inside UIKit, you would have a UI navigation controller. It's kind of the same thing here with the nav coordinator view. So the first thing we're going to do is we're going to create us a new SwiftUI view. We're going to call it app nav coordinator view. And make sure that I've got my reference here all set up. Okay. So now that we're in here, what we're going to do is we need to, this actually is going to be a lot more simple than you think it's going to be. But the concepts might be a little higher level. So what we're going to do is we need to say navigation stack. We're going to have a path. And this is right now nothing because we haven't set up the coordinator to handle this yet. But this is actually going to be a path. We're going to leave this blank for the moment. We're gonna incur some errors on this for right now, but that's fine. And then within that navigation stack, we're going to have our coordinator. So very, very bare bones right now. Okay, so we're going to have to end up making the coordinator before we move on with this. But this is what it's going to be. It's just a navigation stack, and this whole purpose of this view is to just navigate. You're not actually going to show anything, or we're not actually going to construct views in here. It's actually the job of the coordinator. It's going to be a little backwards than most traditional SwiftUI is. I don't know, the word traditional with SwiftUI is kind of a misnomer because it's so new, but things are going to make a little bit more sense here in a minute. App nav coordinator. This is where pretty much all the magic happens. Now, with this one's going to be where a lot of stuff comes into play here. First thing we're going to do is we have to define a type for the navigation view, the coordinator view, to basically understand. So with each one of these navigation stacks, there's a path. This path is usually either an array of something, or off the top of my head, I believe it's just called the navigation path. Okay, yeah, so it is called the navigation path. So the navigation path, and I'll actually show you real quick what that looks like. It's, if I can move my window up here. This is what I mean by when I say navigation path. And I'll minimize it just a little bit. So there is this idea of a navigation path, which is an actual struct. And what this does is it type erases whatever you're trying to use for that path in the navigation stack. So if I come down here, this is what I mean. So it's going to take a path, which in this case, in this example, it's the path state.path, which is right here, my model object, which is defined right here. And this just has a published variable called path. Personally, this is only really useful for, I found it more useful to use an actual array of things like hashable values, because it's more easy to define it. And using NavigationPath, I personally have not found a way to manually edit the stack in this path. So it's useful. You can actually pop things off and push things on very easily. But as far as actually dictating each level of the stack, I haven't found any way to properly do that with the navigation path. However, SwiftUI does allow us to define an array to use as the path. And that makes a lot more sense, because in an array, you can actually say, I want the first screen to be A, I want the second screen to be B, but maybe I want the third screen to be D and then C. With an array, you can actually dictate the order of those screens, and then SwiftUI will accommodate that and navigate accordingly. So the first thing we want to do is we actually want to declare that path. And for this case, I'm just going to say screen path string, and we're going to make it identifiable. And we're going to say var id string return self.raw value. So SwiftUI will take this and say, hey, I know path enum, remember raw value, should have a raw value. Because I have no cases yet. Home, case, register, case, login. And these should all go away. So, okay, so here we have 3 routes: home, register, login. As you scale this up, you might have to get a little bit more clever. This enum, using an enum is actually restrictive, because if we have only one app coordinator view in the entire app, then we have to declare all of our paths on this enum. That can be kind of cumbersome. Now, what you can do is you can use an enum within an enum. So, or what you could do is you could just say the path is hashable, or it's a more generic type that these enums can fulfill using the raw value on here. But scaling up, depending on your needs, it might change how you actually construct this path. But anyway, for this, we can just use simple enums, which is, for the majority of the part, you should be able to just use enums. We're going to say class app nav coordinator. This is going to be an observable object. And then what we're going to say is we're going to actually say at published var path equals screen path. And we're going to be using what I mentioned up here too. When we clean out this path, we make it empty, it's going to default to the root screen. So then what we want to do is we're going to make a couple things here. First, we're going to say we have to have our token storage passed in. And this is where dependency injection comes in. Now, for this, because this is our app nav coordinator, this will always be loaded in memory, or it should. If it wasn't, what I would do is I would actually create a app configuration object. And then what I would do is inside the main view, so basically the root of the entire app, I would construct that app configuration here, and then I would inject any shared values into the root view. And then personally, I don't use environment objects unless it's for theming or settings. And the reason I don't do that is because I've seen developers in the past use the SwiftUI environment, and they misuse it in such a way where it will refresh entire view hierarchies that shouldn't be refreshed. And that could cause issues when it comes to SwiftUI navigation, because if certain values that the navigation expects to exist for a screen to stay on screen, if those change through the environment that is expecting, it could dismiss views, it could reroute views, it becomes a whole mess. I personally try to stay away from the environment They're basically just overglorified singletons. And because it's tightly coupled to the view system of SwiftUI, I've just seen it cause so many issues. What I tend to do is I tend to create objects and then pass them into the initializers, and then have almost like a chain where you just pass whatever is needed into subviews from parent views through the initializers. I've seen it work a lot better. It's better to isolate the data rather than have reactivity all over the place, which I've seen cause issues with new developers, and it can also start introducing some very cryptic and weird errors with SwiftUI. I tend to stay away from that. You can use it as you will. I know that some people are very successful with it. This is just my pattern. So back to the app nav coordinator. So basically, I'm just going to use composition and just instantiate these here without a configuration object to do this for me. So we're going to say let network handler equals network handler. We're also going to have, as a convenience, we're going to say var is logged in. I can't spell. Token storage dot get is not equal nil. So this is just convenience. We're going to need this for our initial root view. Basically saying that if there is a token stored in keychain, then we're considered logged in because we can make network requests on the back end. If there isn't, then we're logged out. Okay, so before we move any further, there's one thing we have to do. We have to actually make the code that will create our views, because we can't route anywhere unless we have the views created, right? So we're going to create an extension and call it config. It's going to be private. So this isn't actually going to be accessed anywhere else in the app. The idea is we just want one spot in the entire app to configure each of our SwiftUI views. It's a little backwards from what everyone might be used to when it comes to SwiftUI, but I found that this actually works fairly well. The point of these coordinator patterns is one coordinator, if you have a sub-coordinator, should be in charge of its views. And if those views are shared, then you should split that coordinator off into another sub-coordinator that owns just that one view. And so your coordinators are composable and moved around. And the reason I do that, and it might sound a little weird because SwiftUI views themselves are actually composable, and there is some argument on whether or not you should have all of your functionality and logic inside of a view because they're structs and they're not technically views. There's this whole argument out in the community right now. But what I like to do is I like the coordinators to be in charge of the setup process. The coordinators are the ones that are in charge of passing around any model layer things, any business logic objects that should be shared across the app. That's their job from this architecture. The views themselves and even the view models, all the view models' job should be is to acquire that and then do something useful with those business logic layers. The view should just be in charge of viewing the data. You can have inside of the views that I make with SwiftUI, you can have transformations like I want to change the string I get from the view model into a certain format. That's all fine and dandy. Any larger logic changes I usually handle in the view model, but that's essentially what this architecture is the coordinators are in charge of passing things around and storing business logic objects and then passing those off to the view models. And then the view models are in charge of passing any kind of calculations or business logic handling up back to the view. It's basically the same architecture that UIKit has with this, but just in a very SwiftUI way of doing it, if that makes sense. Okay, so this is going to look a little weird because of the way View Builder is. And I'll explain what I mean by that in a second. So the first thing we need to do is we're going to say at View Builder func configure HomeView. This has to be some view because it's an opaque some view. It's an opaque type. Now, if no one's ever explained this to you, this some view is basically saying that this function is in charge of defining what type is returned. If you're using generics, the caller is in charge of defining what type is returned or passed in. So now that we have this, we're going to say home view, view model, and we could say in it here, but for right now, we're going to have to change this here in a minute. So the thing about these view builders, and once we really get down into it, that you'll see is we can't actually configure any view models. We can't say let view model equals home view model, right? Home view dot view model. We can't actually do this. And the reason for that is it's a view builder. It's expecting the inside of this function, it's just like a SwiftUI view. You handle it the same way. So you can still have like if statements or do like dot environment equals whatever in here, but you can't actually configure these things. Now, if I wait a second, it might complain to me about this. Unless they changed it. They could have honestly changed it, but if I go to build this right now, I'm assuming that this is going to cause an issue. Well, there's one of them right there. Go back and try to build it again. Oh, they did. Okay, so maybe we can actually do this. Shoot myself in the foot here. In the past, what I've seen is a lot of times these view builders, they don't actually allow. In the past, I've seen it where if you try to do something like this and configure a view model, it wouldn't work. Was never used. So here's what we're going to do. We're going to change things up a little bit. Do that. We're going to try to build again to see if that works. Cool. We can actually do it right in here from now on. So, well, then I guess one of those issues that I had before is solved right here. This wasn't even more than 6 months ago. I was working on an older project. This might have been updated with Xcode 15, but in Xcode 14, if I tried to do this, it would cause an error because of it was within a view builder. But it looks like that's not the case unless... I wonder if it'll let me do this though. Yep, that's what I was coming across. So you can instantiate variables, but you can't actually do anything with them because this is within a view builder. That's what it was. Okay, so this is why got this. So basically in this pattern, I create a separate function alongside the view function to make the view model. And then here we can say make home view model. And this is the same thing for each screen. So basically the pattern, I have to say self. Basically the pattern here is we are configuring the views much the same way we did in the UIKit version. In the UIKit version, we just inside of our coordinators, we configured the views, we instantiated the views, and then we returned we basically added the views to the view hierarchy. This does the exact same thing. Now, one thing to note is some people asked about the delegate pattern here. This is where it comes into play. So now what we can do is we can say mark home nav delegate extension app nav coordinator home nav delegate is func on logout tapped, and we're going to have logout code here. So then the view model is passed into the view. The view, when it has any kind of action, it's going to actually handle that by sending those actions to the view model, which handles the business logic. But now it technically handles the actions, which is not traditionally what a view model does. But I've actually seen this work really well, especially since all we're basically doing is we're handling when we might be handling some data. And then we're just passing handling of the navigation back up to the delegate. So technically speaking, it's still used as a proxy to different objects. Traditionally, view models were just business logic layers. In this case, it's maybe a new name is needed for this rather than a view model, but it's still becoming a proxy, and it's passing the responsibility of delegation still back up to a delegate object. That's what delegation is. So this is how it's set up. We basically configure the view the view model is now in charge of handling the action, so we pass the delegate onto that. In the past, in the UIKit version, we would actually have the nav delegate on the view controller instead. So let's move on. Let's keep going with configuring our views here. So we're going to have another, we're going to say func make register view model first. Say view model. Say return model dot nav delegate equals self. Okay, so same thing. Then because I'm already here, let's just go ahead and make the login nav delegate as well. Okay. Login nav delegate. Yeah. Again, with this whole mark thing, it makes navigation using this dropdown much easier. Highly recommend everyone use this. It makes everyone's life so much easier. If you don't use this right here, that's fine. You can also you can hit Control 6 to enter this, and if you start typing, it'll actually give you the suggestions in here. Really nice to navigate around. One of the nice things about Xcode, I've got a love-hate relationship with Xcode, but I do enjoy that. Okay, so now that we have all the delegate methods done, we can continue on this. So we're going to say another view builder. Oh, we could probably also mark these too. And if you're wondering what these ones without the little dash looks like in here, pretty much the exact same thing. They're just nested a little bit. So we got that. So now the next thing we got to do is we have to make the actual register view. Okay. Register view. Register view model. Now we say again, make sure I didn't miss anything here. Configure is probably a bad name. Maybe make LoginView is a better name for that, but we'll leave it the way it is for right now. Cool. So that's pretty much what it is. So just like in the UIKit stuff, all we're doing is we're configuring the views, and then we're going to be handling all the navigation right within this one object. So like I said, each of these views has their own nav delegate. When it's tapped, then what we're going to do is we're going to adjust the path. And then this app coordinator view is going to automatically handle that path for us. So now that we have those two things all set, now what we want to do is we need a couple things here. The first one is we need a root view. So the thing is, actually, now that we have the path here, it's probably a good time to go back to our view, and it's more easily explained if I just show you. If I can actually delete this row here to show you what I mean by that, what's going to happen. So what we need to do is we actually have to have the coordinator in here. So we're going to say at state object var coordinator app nav coordinator equals dot init. And then within here, we're going to say coordinator dot path, right? So, but this navigation stack has to, this is one of my gripes with SwiftUI too, but this navigation stack has to have a view in it in order to show something. So you could say like empty view, and this would compile just fine, but it has to have something to land on, which it's kind of a gripe for me, because in UIKit, a navigation stack, it has a root view, right? And you can actually change what the root view is. And if you change what the root view is, in UIKit, the UI navigation controller actually has a nice animation you can use for that. In SwiftUI, it's not out of the box. So you actually have to declare what this root view is. And one of the misnomers is this path doesn't have any control over this root view. You actually have to control this root view in a different way than using this path. That's my gripe. Is I think this path right here, whatever is the root view, the zero indexed path, should, in my opinion, be the root view, but it's not. So actually, if I go back to the app nav coordinator, if this path is empty, this navigation stack will default to using whatever view is wrapped within it. That's the root view, not what's in this path. As soon as you add one path to this, it actually pushes on top of whatever's in here. So in my opinion, everything should be handled by this one path. It would make life so much easier, but that's not the way it currently is. I'm hoping they change that in the future, but that's my one gripe with this whole pattern is you have to manage the root view in a different way than what is afforded to you by this path object. It's a little bit dirty, in my opinion. But in any case, what we have to do is we have to handle that root view. So we say at view builder func root view sum view. So and this is where we start using the is logged in here. So we're going to say if is logged in. Then what we're going to do is we're going to say configure HomeView. Else we're going to say configure LoginView. And that's what's going to happen. So now we go back into the app nav coordinator here, or app nav coordinator view. We're going to say coordinator dot root view. And at this point in time, we should be able to build this and then refresh this screen, and it should be the login screen. There we go, right there. So what's happening now is the coordinator, because it just got initialized, there is no token storage because we're in previews, so there's not going to be any token storage. And it's saying, hey, are we logged in? We're not logged in, so show the login screen. And that's what's showing right here. So now that we have that, we have to figure out a way to handle all of our other screens. And I do this with another view builder. View for screen, and this is where the enum comes in. Path, screen path. It's going to return the opaque type sum view. And then we're going to say switch screen path. And this is where we just say configure HomeView, configure LoginView, configure RegisterView. That's it. So this is where the magic really happens, where we're saying whatever path you have, so the screen path right here, use that. And when the app nav coordinator view says, I have a new path, give me a view for it, it's going to call this and it's saying, hey, okay, return the home view, return the register view, return the login view. And because we've already done all of the work of configuring it, this is all it boils down to. We don't need to do anything else here. So in the coordinator view, come back in here, we have the root view. Now we have to say dot navigation title display mode. Well, this doesn't really have to do with navigation. This is just visuals. Navigation bar title display mode. We're gonna say dot inline. I don't like that. I don't like the big title display mode in there. I just personal preference. Navigation destination for. Yeah, this is it right here. I'll leave that placeholder. And this is going to be screen path.self. So we're expecting this path to be of type screen path.self. But if I go back, it's hashable, right? You can use just raw strings for this, which might be the solution to scalability on this. But for our case, we're just using the screen path.self. And we're going to say the path. And then from here, we're going to say coordinator dot view for screen path. Cool. Actually, I'm thinking if this refreshes, I probably could just, I don't know if navigation actually works in the preview. I don't think it does right here. In any case, so what's happening now is, again, like we had before, the coordinator.root view is handled from this root view builder that we made inside the app nav coordinator. Then we say whenever the path changes, because remember, the navigation stack is always observing the path variable from the app nav coordinator. So when we change that inside the app nav coordinator, it's going to bubble up to the navigation stack, and the navigation stack is going to then, within its views down here, is going to say, hey, the path changed. So this right here is then going to receive that and say, hey, the navigation destination changed to this path. We need the new view. And it's going to delegate that back over to the coordinator and say, okay, well, return that view for that path. This is it. This is all we have this is essentially a UI navigation controller in one view. That's what we kind of recreated here. It's just the UI navigation controller. Kind of a roundabout way versus if you just use it in UIKit, it's just a straight one object, you just handle it. But this actually does work fairly well. I was pretty surprised, pleasantly surprised. I personally don't use this navigation in my big enterprise projects, but for new projects that are small and simple, this actually works really well. I'm sure you can scale this up. I personally haven't scaled this up to enterprise level platforms, just a personal choice. But if I was, I would actually be doing this. And I did start a client. I did start configuring a client project or refactoring a client project that was built all in SwiftUI, poorly, I might add, to these patterns. And it was starting to work very well. So let's see, what else do we have here? So that's all said and done. So now that we have that, all of our stuff here. So why don't we do this? Why don't we just handle navigation real quick, and then I'll go back and we'll make the view models. So down here, what I'll do is right here, let me minimize some of this stuff just to clear it out so we have a better idea of what's going on here. App nav coordinator. I am adding this here. Mark navigation path logic. This is where we're going to start handling that path object within the right here. So we're going to start editing this from within this extension. What we're going to do is we're going to make a couple convenience things, and then we're going to basically actually these are basically all convenience to be honest. Var current page screen path. We're going to say guard path.count is greater than 1, else turn nil. Turn path.count -2. Basically the current page. So I was actually looking at the wrong thing. I had to pause for a second. I was like, this doesn't look right. This is actually previous page. Look at my notes here. I saw the -2. I was like, that's not right. That's previous page. The current page is much easier. That's just path.last. We check to see whether or not the path is greater than 1, because you have to have 2 pages on there to have a previous page. The issue with these, again, it doesn't take into consideration the root view, again, because we have the path here. But you can just make the assumption that there's always going to be a root view, and that this path is always root view plus whatever's in the path. Yeah. So then we're going to say func push page, call that path. I'll call it page. Screen path. And my terminology in this project's a little all over the place, but bear with it. Bear with it. Say func pop. We're essentially recreating exactly what the UI navigation controller did. So path.remove last. I have seen libraries start to pop up all over the open source GitHubs where they attempt to kind of automate this for you. Personally, I don't think you need all that. A lot of iOS developers are purists. I try to stay away from third-party packages. This is not that hard to do. It is a little bit more boilerplate, but once you get it, it's so much easier just to have it in here. It's not that much. Okay, so we have this in here. So these are just convenience. So now what we want to do is we want to go down to these delegate methods and handle it. So we're going to say home delegate. This one actually we need to log out. So let's go back up to the top and create a logout method here. Say func logout. And this one we're going to do is token storage dot delete. And then we're going to say path equals nothing. So this basically just saying go back to the root view when you log out. So, and we want to delete the access token from keychain whenever we log out, because if we don't, the system is going from this root view right here. If we don't delete it, the is logged in is predicated on whether or not that exists or not. So if we didn't delete it and we just set this, it would just go back to the home view again. So you want to make sure that that's actually removed whenever you log out. Okay, so now that that's in place, let me minimize some of this stuff here again. So we just need to say log out. Okay, let's open these up. Okay, so on logout tapped, we're going to say path equals dot login. On register complete, we're going to say path equals default back to the root screen. This is an issue right here. So this is actually a bug. So if we set this path to login on login tapped, from the register, what it's going to do is it's going to push the login screen back up. But we actually don't want that, so we can go back down to the path here. So this is kind of the same thing. We could actually combine these. What's basically happening is when we are on, this might be easier if I show you what's going on here. I'm out of full screen mode to show this. Okay, so what I'm talking about here is if we actually put login here, we go to register and then we hit login right here, you'll notice that we still have this back button back to the login screen. That's what the issue was there. Now, the reason for that is we pushed 2 login screens on there, right? So we have the root view right here, which already has a login screen because we're logged out. And then if we added the .login here, what we would have is we'd have a root view that's login, and we'd also have one login on this path. So we'd have 2. And that's what's happening here, is we have the login that's pushed on the path, and then because it's pushed on the path, the navigation stack says, hey, you can actually back out of that, which is right here. Boom. So that's why in this case, what we want to do is we want to say, just let the root view view builder handle this and just make this empty. It's a very simplistic use case. I know it's not going to be too complex with this pattern. In a future video, I'll actually have a more complex use case for this. That'll have like subflows, sub coordinators, and all that good stuff. But inside the login nav delegate, when the register is tapped, what we want to do is, well, we actually just go back, path equals empty again. I know the root view, this doesn't make it really clear on what's going on unless you really pay attention to that root view there. One of my issues with it. So we're going to say path equals this. And then in the login, see, unregistered, on login successful. Actually, this path needs to be, oh yeah, we don't have any navigation at all. Look at that. I just realized that all of the navigation in here is unregistered. Let's see here, registration, unregister tapped. Actually, no, there's this one right here is wrong. We have to say path.append.register. There we go. There's one. So this is going to push the register screen on screen. And then once we're in the register nav delegate, on login tapped and all that stuff is going to just go back to that root view. Now, if we had like a login flow or a proper registration flow, you'd have a lot more screens. And then if the register tapped, for instance, you want to go back to the login screen, what we could do is we could just have all navigation on here as an example. So I'll do that now. I'll basically show you what this would look like if we were using this path a lot more, because I just feel like this is a little too light to show you exactly how this pattern really can be useful. So we would do like path.pop or self.pop, and we can do self.push dot register on login tapped. This would be, this is the register, self.pop, unregister complete, self.pop again, and then logout would actually handle logout. So it would look a lot like this. So you'd push views on and then you'd pop them. But because this is such a simple app, and we literally are only pushing one screen on there, and that's we got the registration screen, and then because the root view is handling 2 screens, and we only have 3 screens in this app, the value of this is kind of lost in this project. But in any case, let me just change these back to where we had it. Again, I'll have to go over a more complex use case in a future video, because this is so simplistic, but I really hope that this at least shows you what you can do with this pattern without it being super complex. I know it's again, this whole root view kind of makes things a little bit more not clear on what's going on sometimes. But in any case, that's our coordinator. We're done. So we can move on to the view models now. What we have to do is we actually have to go back in to each of these view models, and we've got to add the network layer stuff. So with this, what we need is we're going to say, what are we on there? HomeView. Okay, so the HomeView is going to be a little bit different. So we're going to have a couple extra pieces of text here. So we have delegate. We're going to say published are show alert. These are for errors. Probably not going to see this in the project, but this is a great way to just show simple alerts. What I've seen in the past is people will have one alert for each view, or they'll have multiple alerts for each view. So they might say like dot alert. They might do one here and then another one for another use case, and then another one for another use case, and you just see a bunch of alerts down there, which you kind of have to have if you have different actions on that, but you can actually still solve this fairly easily by just having a generic one right here. I have an alert. Whenever I show this, I'll just change these before I toggle this, and then it shows the alert. If it's just like a simple OK button alert, this is a great way to do it without cluttering the views up. So from here, we need to also add in the private let work handler. Private let token storage, access token storage. And what we're going to do, yep, there's no initializer. Storage. Okay. So now that we have all that boilerplate in here, so we've got everything we need to actually handle these actions. Now what we got to do is we have to, this stays the same. This actually stays the same. We have to change this on fetch secure data tap thing. So this is where where'd it go? Where'd it go here? Change these network routes come in. So we're going to say let route equals. So basically this function is going to reach out to the server and fetch the secure string that we're using with to acquire with the access token. So this is kind of after the fact. I'm going a little bit backwards here when it comes to creating the view models, but we're on the home view. So at this point in time, we've already fetched the access token. So we're using the access token to fetch a secure string from the backend. So we're going to say let route network routes dot login data method equal route dot method, say guard let URL equals route dot URL access token string equals token storage dot get, and we want the actual string, not the object that contains both the access token and the refresh token strings. We just want the string. We're going to say access token else return, and this is what's nice. We could say info text equals could configure request. We could have also done this with the alert, but we're going to use the alert specifically for error handling here. You know what? I'll actually use the alert here. Alert title error alert message equals this, show alert equals true. That's how we use the alert. So within the view model, you can just handle all that error message, and then this will just bubble up back to the view and then show the alert once it's there. And we can configure this as many times as we want. So for the simple error messages, I'll kind of cheat and I'll use the info text to just show that on screen because it's already set up. But we're going to say task for the background. We don't want to send network requests on the main thread. Say let response data equals try 08 network handler dot request, and we're going to have a response type here, so we're going to use this one. URL okay. Now we don't need content type because that defaults to JSON, which is exactly what we need. The JSON dictionary we also don't need because we're not sending anything to the server. And see, this is where making our network layer, our network layer generic comes into play, because I'm not configuring a new request for here. You see how I can just, because I already handled default values, I can just delete what I don't need out of this actual function body for the parameters, and it just will handle it for me. The response type is going to be secure fetch data.self, and because we're passing in the type, We're not passing in an object, we're just passing in the type of the object, and to tell this method that the generic type is this to decode from. The HTTP method is the method we just did, and the access token is access token string. From that point on, if we reach this part down here and everything worked out, we know we're gonna do the raw value because we need the string, not the actual enum. If we hit this point right here, we know that this request succeeded because it didn't fail. If it failed, it would have thrown an error, so we would have been down here. And we know it's finished because we're awaiting it on this background thread. I really like this async. I was hesitant to use async await at first, but it reduces a lot of code and it makes things a lot more straightforward. So now we need to be on the main thread to run this next part here. Say weak self.infotext equals response data.message. Response data.message. Why is this not showing up here? Something's going on. Here, fetch data. Oh, here we go. You know something's wrong when you're expecting something, it's not working. Yeah, I forgot to put this in right there. All right, response data dot message. Because again, the response data is this secure fetch data right here, which just includes this, just a message. It's just a string message. Let's go back to the HomeView model, and that's all we need. So down here, we're going to say await main actor dot run to be on the main thread again. self.infotext error.localized description. Again, I could have used this alert message right here, but like I said, I'm going to cheat just because it's one line of code and just throw this into the info text. That's it. We're done with the HomeView model. Everything's actually set up. We don't have to adjust the view at all because the view already handles all of this stuff, minus this actually. So I lied. We do have to go into the view real quick. So if we want that alert to show, and we're down here, .alert, say title key presented actions. So title key is ViewModel alert message alert title is presented show alert, and the action is going to be button title key, okay, action. Actually, there's a role in here somewhere, isn't there? There it is. Nope. Cancel. So this will actually automatically handle it. So this alert, we're just saying use that alert title. Then we've got a binding or a publish property that controls the alert. We just have a button that says OK. And then because the role cancel, it's automatically going to handle that for us. And this is complaining right now because this does not have the new parameters we need to pass into the view model. This is just the quick and dirty way to make preview stop yelling at me. Okay, so there it is. There's a home view model. Now let's keep moving on. We're just going to crank through the view models, and then at the very end, we'll just run it, and I'll explain through everything else one more time. Okay, so what we're going to do is we're going to go back into the screens here. We're going to do the login view model next. Let's clear some of this stuff out. Okay, so much like the same, again, a lot of this stuff is going to have the same type of things in there. So what I'm going to do is I'm going to actually go back to the home view model because we're going to reuse this alert message functionality here. Copy paste that. Actually, a lot of this stuff is going to be the same. So let's see here. Storage. Okay. So then come down to the actions here. The register tab is going to stay the same because we're just navigating. The login tab, this actually is the network request. So we're going to say we have to do a little bit of some checks here, because if I go into the login view, it's going to yell at me again. Make this a little dirty here so it runs. Oh, you know what? It's not going to run right now just because I haven't actually updated the ViewModels within the coordinator. But what I can do, I'm going to cheat a little bit here, and I'm just going to show you the it's right here. So because we have fields, we're going to validate these fields. So login view. So we're going to say guard.email.isEmpty. Password is empty. And we can make this one line. Else title missing fields. Alert message equals please enter email and password. Show alert equals true. And we're going to return. We're validating those fields right there. Now we can handle the network request. That route equals network routes dot access token. Method equals route dot method. Let URL equals route dot URL. Else alert title equals location. Error. Nope, I'm hitting too many buttons here. Show alert equals true. Turn. All right, so now we have to make the payload here. So we're going to say, make a little bit more room here for everyone. So we've got to do let JSON dictionary name now password. And like I said before in other videos, the reason I don't make a codable object here is because these are one-off payloads. I just make into a regular dictionary. Less bloat within the file hierarchy here. All right, so we're gonna have access token. Remember, we're on the login screen, so we're fetching the access token. Dot request. This one's gonna be response type again. URL. Again, I don't need the content type because we already know it's going to be JSON and it's defaulting to JSON. JSON dictionary. Response type is going to be of type access token. HTTP method is the method.raw value. The access token, well, there is no access token because we're fetching the access token. So we can't actually include something that we don't have. So, okay, so at this point in time, I gotta have a catch here. So at this point in time, at this line, we know that the access token has succeeded, it hasn't thrown an error, and we know that the network request is finished because we're in a task and this is a async await function. So now we have the access token, so we can say token storage dot save access token. And we say await main actor dot run to be on the main thread. Self in self dot nav delegate dot on login successful. And then if there's an error, we're going to also go on the main thread. SwiftUI complains if you try to update a lot of these observed properties from a background thread. It might work, but it can introduce race conditions. title. It's true. Okay. And there it is. I'm going to bring this down a little bit so we can see it a little bit more easily here. I don't think I can fit the whole thing on one screen without it getting too small, but here's what we have. So we've got the guard email. Basically, we're validating the data. Let me go up a little bit here so it's actually easier to see. Go. Okay, so we've got some validation going on here. If there's an error, we're using the alert that we've created. We're configuring the routes and the URLs here. We have the JSON payload that we're sending to the server. And then we have this task, which runs on a background thread. And then we are using the async await functionality to say, send it out. Oh, this await basically just says, lock this thread, or block it, sorry. Block this thread until we get the access token. If a failure happens, then it's going to throw an error, and we're going to catch it here. And then we're just storing the access token. And then after that, we are considered logged in. So then we say login successful. And then we are delegating the navigation back up to the coordinator that we made earlier. And that is the LoginView model. Now for the LoginView, we do have to create the alert again. But I'm going to cheat because we already did this once. I'm not going to do it again. We're going to go into the view here, and I'm going to come down. I'm just going to copy this alert right here. And then we're going to go into LoginView and paste it in. And everything should be good to go there. So on to the RegisterView model. So for this one, we are also going to have the alert message. So I'm going to copy this stuff in here again. Then we're going to have we're not going to have the token storage in here, but I'm going to copy and paste this in here anyway. Just remove what we don't need, just to save me on type, because we all know how bad of a typer I am. Okay, so now when we come down here, this on login tapped is just pure navigation, so that can stay the way it is. So we're going to minimize that. And then the on register tap. So this is where we need to validate all those fields again. Now, if I show you just a quick example, because the project's not going to build the previews right now, I'm going to go back into the simulator. And this is where we have it. So we're on the registration screen now. We have these fields right here. So we need to validate and then send the network request out, very much like the login view controller. So the first thing I got to do is I want to say guard.email.isEmpty, password.isEmpty, confirm password is empty. And then we got to make sure that the password is the same as the confirm password here. And if it's not, then we need to say alert title equals field error, or whatever you're compelled to put as a title here. Alert message equals check information is correct and yes words match. Show alert true. Then we're going to return from that. So the validation is done now. All right, I'm going to close this so we can clean stuff up. Have a little bit more room to gallop here. Route equals network routes dot register method equals route dot method. I'm going to say guard let URL equals route dot URL else. And this was the same thing down here, so I'm just going to copy this because I'm being lazy. I don't want to type all that stuff out. Okay, so we've got the validation here. We set up the routes and the URL here. So now what we want to do is we need to have a JSON dictionary our payload to send to the server. Say email. It's our email. Password. Password 2. Confirm password. Now we can do the same thing we did in the previous ViewModel task. Do fetch. And we're going to have try await network handler request. And we're just going to have, this is going to be the simple one here. We're not actually going to have any payload, although we do get data sent back, which is, oh, what's going on here? Nope, come on. Which is why we set this to a underscore. We're discarding the return value on this request. This is the version of the request that sends back just a data object. But because we just want to know whether or not it passed or failed, we don't need the response here. This will throw an error if it failed, which is already handled within this catch. All right, there we go. So dictionary, raw value. Don't need the content type or the access token here. Okay, so now that we're here, we know that it worked. We say await main actor.run to be on the main thread again. Say self.alert message. Self.registration. Oh, I forgot a parameter here. Let's see here. We got to come back up here. So we have to add one more property. And the reason we need this, I'll show you here in a second, is because when we register for an account, because we are using the same alert for both error messages and success messages, we are inside the actions area, so that OK button that the alert has. We're going to use this to declare, hey, when the user taps the OK button, what do you want to do? So we're going to set up the alert to say a success message, and then this is going to be true. And then when that success alert shows and the user taps on the OK button, we're going to use this as the indicator that, like, hey, this is actually a success message, so then handle the action differently. Basically, send the user to the navigate away from the registration screen for the user. So we're going to say, in here, we're going to say self.register successful equals true. Self.alert title. Self.message. Activation email has been sent to email. Self.show alert. True. Then we got to handle the error right here. So let me move up a little bit. Await main actor.run. That's done. So let's go over this one more time. So registration view model, we have the onRegister tapped. We're doing our validation here again. We are setting up the route and the methods. We've got our JSON dictionary, so the payload we send to the server. We send it to the server using our network handler. If it's successful, we're going to reach this code down here so we know it's successful and we know that it's registered. And then we include the email in our alert message just as a little convenience to the user to say, this is the email you used to sign up. Then we show the alert. Then we handle error messages. Cool. So again, because we have this special alert message here, what I'm going to do is I'm going to go into the LoginView. I'm going to copy this. Then I'm going to go into the register view right here. If you didn't know, these little like breadcrumbs right here, you can actually tap on these things and switch it out. So this is the directory that this file is in. I could just pop over to the view real quick. And because the previews aren't going to work right now, because I still haven't adjusted the coordinator for our view models, I'm going to close that window, and then I'm going to paste this here. But again, so we've got a show alert. Actually, there's one thing I'm missing in all of these. It's the message. Totally spaced my mind here. Message. So let's go back to the other views here and LoginView and just add that real quick. Message. Have the home view. If you're wondering what keys I just tapped, Command Shift O brings up a little search within Xcode that you can just start typing in whatever you need. So register view. And you can hit enter and that navigates to whatever screen you need. Okay, so within this action, actually make this into a, handle it this way. We're going to say if ViewModel.registration successful, then we're going to say ViewModel.navDelegate.on registration complete, or on register complete. So technically speaking, I could probably make another action within the view model to handle this rather than directly calling the nav delegate from within the view. But for the sake of it, I'll leave it the way it is. Okay, so that's it. So we're done. So now what we have to do, one last thing, we've got to go back into our coordinator here. Not the view, the actual coordinator object. We have to fix the build issues we have because we added properties or parameters to these view models. That one's fixed. Let me see. Handler. And we've got to go back down here to LoginView. Handler. Storage. Now that all that's done, we should be in good shape. So let me rebuild the project to make sure there's no lingering issues. And there is. Where is it? Oh, haha. So, okay. The one thing that I didn't do, we have to go back. This is from the last video. We have to go back into the root of the project and actually switch this out to the app nav coordinator view. View. Make sure that coordinator view. So we're using composition here. Cool. Okay, so let me rebuild it. Make sure that we don't have any issues. It succeeded. Okay, let me close down the other simulator, make sure that I'm not running it on the same one here. Okay, so real quick, let me just show you the backend project. Close down some of these right here. And this out. Okay, so this is the database. I'm cheating a little bit here, but this is the database on the backend. This is currently running. So if I go back into the terminal here, you can, or no, where's the debug? So we can actually see the network requests coming in. So what I'm going to do is I'm going to delete the user that I have here. Submit that and delete it. So now we're going to go back into Xcode. We're going to run the project, and then we're going to go through registering a user, and then we're going to use that user to fetch the access token and then log in. Okay, so everything ran just fine. Now you can see we can go back and forth between the register screen. It's not registering my clicks here for a second. Okay, that is not working for some reason. Fields, the register button is broken. Cool, let's solve this. So let's go back into let's go from the top down. So when I usually debug, I like starting from the top down. And the reason for this is if I don't get, so register on, let's see here, we're on the login screen. Login screen on register tapped. Ah, right there, I can see it right there. We actually have to push. Yep. back when I was removing all this stuff. Some of you noticed this before I did, I bet. All right, let's rerun the project. I'll hit register. There we go. Pop back, forth. If I hit register, if I hit, let's see here, login screen, I hit register, and it's not going to the register screen for some reason. That's interesting. Unlog in, I push the register screen, so that must mean that we've got an issue up here in our view for screen. Register, I switched them. Yep. How many of you noticed that before I did? But you see how easy it was to figure that out though, right? So when we were in here, we were very easy. We could actually track down, same way with UIKit coordinators. We can actually just go down here, see where the actions were, see what the navigation is like. Okay, this pushed this, that went there. Here's what it's returning. It's very easy to solve navigation issues with this pattern. So let's try this one more time. Register. We are on the register screen. Cool. Login pushes it back to the login screen. Back button works. Okay, cool. So what I want to do, for the sake of everyone watching, is I actually want to show in real time what happens on the back end. So what we're going to do is we're going to hit register. And when I register an account, what you're going to see is you're going to see this terminal post an update for the endpoint that we hit. So I'm going to use the same username at example.com. This is not my name, by the way. I just used John Smith and generics. Password tester123. Tester123. We're going to tap register. And if it's successful, it should show up down here. Didn't do anything at all. Oh, there we go. Huh, wonder why it took so long. It's probably simulator stuff. So in any case, it hit it. It was a post request at API register, HTTP, and it was a 201 response. Then we see now that the registration alert showed up, and we hit OK. We should navigate back to the login screen. Okay, and we automatically navigate back. Now, if I refresh the database here, you can see that we now have a new user called john@example.com. Now, I'm going to cheat like I did in the last videos. I'm going to activate this user directly from the database rather than go through the whole email process. Well, for one, we used a fake email, so I wouldn't receive it anyway. So let's see, just make sure I committed that. Everything's all good to go. Okay, so now we can log in. We say john@example.com. I'm going to say tester123. Then when I hit submit, you're going to see another request hit the back end right here. Submit. And it was a 201, and it was to the token endpoint. So now we actually have a token on hand. And then the default text is gone here, but if we hit fetch secure data, we see the you are logged in. If we hit reset data, get that as well. And we can do this as many times as we want. See how it keeps getting hit down here? Let me clear these real quick. So if we hit reset text, fetch secure data, it just keeps hitting the endpoint that we have there. Now let's log out. Okay, so this logout button's not working. It's actually a really easy thing to solve for because I didn't actually set the nav delegate. So, all right, now that that's done, let's rerun the project. Now when I hit logout, we go back to the login screen. Now, what you saw there was the navigation didn't have a nice animation to that. There might be a way to solve it. I didn't go too far into animations or navigating when it comes to switching out the root view right here. But feel free to do that on your own time. But that's it. That's the entire app right there. So we went over quite a bit today, but only 2 videos. We only had 2 videos. So what is that? Like, a couple hours maybe to set up an entire project, set up all the views, all the view models with SwiftUI, and do everything. We went over quite a bit today. I know that the coordinator pattern, the way at least I do it, is fairly different than how most others do it. But I found that this delegate pattern really works well to set up and organize the flow of things and to reason about it. The reason I like this is because in one coordinator, I can see both where the views are configured, how they're configured, and I can track all of the actions that deal with navigation and then how that navigation is handled from within this. So I'm not looking all over the code, which was the benefit of UI coordinators. Coordinator pattern is used to isolate navigation logic in one spot so you can follow it much, much easier. And I'll just have to do a whole video on this at some point, but there you have it. There's authentication in SwiftUI. Again, what I'm going to do is I'm going to add links in the description below for all of the UIKit videos that were used to build the model layer stuff and the access token storage. I go a lot more in depth on those videos. In the next one, I'm going to recreate this exact same app one more time. I know I'm getting kind of like overboard here with this iOS authentication, but I think it's really important and it's a really good use case to show these different navigation patterns. I'm going to do the same thing, but I'm going to use the navigation pattern that I use, which is basically the UIKit version, just wrapping all of these SwiftUI views in hosting controllers and using the UIKit navigation. So yeah, with this one tutorial, you'll get all three of those. Maybe I'll even add them to a third playlist. But in any case, real quick, we make videos once a week. So I usually upload videos every Sunday. That's usually my day to do it. And yeah, so without further ado, that's it. Hope you learned a lot. Happy coding.